Bam, bam. Hello, my name is Ethan. I'm in group 4 and I'm going to be presenting a video on RoboTA, which is our group's semester project, our AI chatbot that we have specialized and designed to assist as a teaching assistant. As I said, I'm Ethan, and our other group members are James, Elizabeth, and Alyssa. So the purpose of this agent, as I said, is to specialize in teaching assistant tasks, and the way we did that was created a local knowledge base of important like lecture plans and teaching strategies that we want this to pull from. So the primary technology we used to enable this is OpenRouter. So let me take a look into the code so you can see how OpenRouter works. OpenRouter is an API that has access to lots of free models in their backend, free models from a lot of different companies, and what they allow you to do is set a config file or a little configuration variable. They give you an API key, and then you set into your config the name of a model, and then they'll give you the name of the model you use and a prompt, and when you make a call to this model, it will send that call through OpenRouter to this model's backend straight, and then get its reply back for you to use in your code. It's a really cool system. So how this is implemented, this is a web app. So we're running this in Flask. That's a Python-based interaction with HTML that lets us put up a website. So as you can see here, this is in a Chrome browser. But how we implemented this system in the back end is pretty interesting. So this is a modular prompting service, basically. How this works is when I type something into this message, say, write me a haiku about, say, goldfish. So this prompt is getting sent to the main MetaLlama AI that we're using in the assistant file. And then what MetaLlama chooses to do, it sees that it can use one of these 3 tools: retrieve, research, and write. And if the prompt matches what one of those tools is described for it to do, it will make a subprompt for itself to answer and send that subprompt to one of these files. So let's see if it did this here. Yeah, so when I asked to write a haiku about goldfish, it recognized that I wanted to use its writer tool to write a file and save this haiku. So it made our prompt and then started a subprompt and made sure it could successfully save that file. So now, if I look in our local knowledge base here, I have this goldfish.txt. This is a file that it created and saved on its own, and it has the exact same thing that it prompted for us, which is great. So when it sent to writer, this was a separate submodule construct, and that submodule was able to write that file. So this is easier to explain with this architecture. So the user interaction prompts the assistant. The assistant prompts its submodules, and depending on what it finds will be useful, allows the submodules to do their job. Right. So local knowledge, as you saw, we have files inside of the operation of this thing that keep a lot of text. This is one that I inserted about experimental teaching practices because I wanted to be able to pull some of these whenever I wanted. If I say that I asked the TA for a new strategy to keep people engaged in my talk about AI destroying the world, what can I do to assist here? I would just type retrieve the introduction, sorry about the spelling, of my file on experimental teaching practices. And since this is a submodule, it's going to take a little while. But there you go. See all of the information in that file that it deemed important to my prompt, which was very simple, so it pulled a lot. It retrieved that information straight from the file, printed it, and now I can say which evaluation metric, I'm going to go off these 4 here, should I focus on to measure class participation? And it's going to remember this thing that it just said for the next prompt, which is important. It shows student engagement levels, which is the first one. Great. And then it explained it there. So yeah, this is a cool local knowledge system that James figured out how to write up. And so we've written and received from these files. As for degree of completion, what you can see at the very end is our researcher tool was not implemented. This was the plan was to allow our third tool to provide search results from either Google or DuckDuckGo. And that's really hard because you need those services' APIs to be able to search. And diving into those APIs and even being allowed to use them was a challenge we didn't get to complete. But writer and retriever seem to be executing flawlessly. Anyway, yeah, I don't want to make this too long. You can sort of see why this would be useful to a professor that just wants a little bit of extra advice, and specifically on the files that they have in local knowledge and want to pick something to focus on from there, or maybe write something to there. It's I'm very proud of it. So yeah, thanks so much. That was RoboTA.